Okay, so now we come to the practical part, and let's do this together. So I will now, or maybe I still share my screen. So I would now like all of you to have a Fiji on your computer, if you have. So we can now take a couple of minutes to do. And then add an update site that's called Mobi. So maybe what would be nice if you could in the chat just indicate whether you intend to do this. So maybe just write yes, just to have a feeling who wants to really do this. Okay. Excellent. So this is okay. Then I think I'll just shut up a little bit and wait and ask, and then if you have questions. So these are my instructions here. If they are not sufficient, then you have to speak up. I sort of thought most people already at some point in their life an update site to Fiji, so I was hoping. Okay, and then you could maybe also type done in the chat if you managed. Yeah, and again, just ask, right? You don't have to be, I mean, just that's why it's a workshop. So the more you ask, the more fun it is for us. Okay. It's good. And now comes the moment when I'm really nervous to see whether all of this will work. Of course, good workshop last night update and stuff. So okay, that looks excellent. So I will now copy an HTTP address into the chat. And don't click on it, okay? This will not do anything interesting in your browser. But instead, go to your Fiji, and then we do it the cool way. We click into the search bar and we type OME space. OME space is already enough. So I highly recommend using the Fiji search bar to do stuff, because you usually discover things that you didn't know existed. For example, I didn't know that there is a visualized OME metadata, which looks interesting. So it's really good to find things that are similar to what you want to do. So the thing we want now is open OME SAR from S3. Okay, and that's, as I said, basically the object store. So none of the others. Okay, there's 3 of them. We need the one at the bottom. I hope that works for everyone. Again, otherwise just speak up. Okay, then I click run, and then you simply copy and paste the web address from the chat, and you also say yes, please log the chunk loading, because that's kind of fun to look at, to kind of appreciate what's going on. Okay. Good, and then if everything goes well, you should all have Big Data Viewer opening up with this Platina Reis data set. Please, can you indicate in the chat, say yeah or something if it works? Yep, done, yes, see. Okay, good, my adrenaline is going a bit down now. It's a good start. Yeah, you did, that's the spirit. Okay, first of all, I don't know if this console window popped up for all of you automatically. If not, then there is window console, so you would have to actively, for me it's sort of sometimes like that, sometimes different. So this is actually now interesting to see because it tells you which chunks it was loading, right? And you see, for example, and I think the logic is the higher the number, the lower the resolution. So first it loaded some stuff from the lowest resolution version that we have. And then again, these indices now are just the ones that I told you before. And since this is only a 3D data set without channel and time, there are only 3 indices. So these 3 indices are about X, Y, and Z. And then it tells you, so you see, we actually, and this is a decision one can make, stored the data such that one chunk is about 1 megabyte. And I have a feeling that's a bit of a consensus that that is a reasonable size, yeah, not too big, not too small. And then you can also see how fast your computer was loading that. And that would be actually, I don't know, if you want to be, I would be curious, you could in your head try to make an average of these numbers, how fast your access is. I think for me, it's maybe really fluctuating, but I would say 20 megabyte per second is maybe my loading speed. And I'm very close. I mean, I'm sitting basically literally 10 meters away from this data. So I would be curious what kind of numbers you get here on average. Okay, Christian Schmidt. Christian Schmidt, where are you?
I'm at the DKFZ in Heidelberg.
Oh yeah, that's also close. Okay, Australia. Oh, that's a really interesting. Okay, 0.6. Okay, cool. Yeah, that's lower. Okay, actually, I think I can make a note. Australia. This is really fun, actually. So this is probably worst case. Okay, 0.6. Okay. To know. Minus 10. It's uploading. Okay, cool. Okay, so now we can move around a bit. For example, if you use your mouse wheel, if you have one, then you can scroll up and down in these set planes. Aha, and it was actually caching a bit for me now, only now. And then you see at some points it's starting to load new stuff, and then your console window. Wow, it cached a lot here. Amazing. I have to scroll really far that it loads something again. Interesting. Okay. Another thing that's interesting to note is this red stuff, which in fact is not a warning. That's a feature of OME-ZAR. So you see there's a lot of black space, right? And storing all of that is sort of a waste of time and energy. So what's basically a feature is that you can have missing chunks, and if the chunk is missing, then it will basically just fill it with zeros on your computer. Okay, so this missing is not a bug; it's a feature. Okay, so this is one thing. Then, if you use your left mouse button, hold it. Okay, actually right mouse button, and you can move around left, right. So this is different than left mouse button. You can actually tilt the whole thing and then look at it from the side. So this requires a bit of practice. And then with your arrow up and down keys on your computer, you can zoom in somewhere. Okay, and then it will take now more or less time to load the full stuff. Okay, and I think you have to agree this is pretty neat, right? So we can all together look at the same 8 terabyte data set with our mediocre laptops. So that's,
and the server hasn't crashed yet.
No, and actually I wanted to, I forgot, I wanted to ask, our IT guys to monitor the thing now and see how, well, I don't know, but okay, my loading speeds are slower than before. I don't know, maybe that's because we all do it at the same time, yeah. But it doesn't crash, it's good, yes. Okay, any questions here? No, okay. Then I will, maybe you can close. Ah, yeah, Nicholas is getting faster. That's, I'm slower. Maybe there's some global balancing going on. Okay, then maybe we can close this, not the whole Fiji, but just these things for now. And actually, okay, just maybe it's obvious, but when I zoomed in, okay, now we are loading from the higher resolutions, right? So that's basically the concept. And then I will talk a little bit again, and then we do again a practical together. So I go back to my presentation. So that's that, okay? So this is one thing that OME-NGFF can give you. You can share such big data with other relatively painless. So I want to chat a little bit about multimodal data, because that's also something we really want to sort of solve with OME-NGFF. And this slide sort of summarizes the concepts. Yeah. So if you have multimodal data, for example, we had actually for this project, we had this EM data set, and then we had the same physical space of this specimen image, but with light microscopy, obviously at much lower resolution. And that means these images have much less voxels. Okay, so in voxel space, they are very different. And that means, for example, that in just like the classic ImageJ viewer, you could not show them on top of each other. Okay, this is not possible. It will complain. It says they don't have the same size, because the ImageJ viewer is sort of a voxel grid philosophy viewer. Okay, but big data viewer actually has a different philosophy. So big data viewer in fact says, I know nothing about voxels, I just know about physical space. So when big data viewer wants to render something, it's sort of just going through the canvas that it currently displays, and then asks all the images that are currently visualized, hey, can you please give me a value that I should render, okay? And it asks these images by means of a transformation that actually specifies how to go from voxel space to physical space, okay? And the easiest, and that's also what we will see later, thing is that you all know is just voxel size, okay? If you think about this voxel size or image calibration in a more abstract, or I don't know, or more general way, it's actually, you can view it as a transformation from voxel space to physical space, yeah? So basically by multiplying each voxel with a certain scale. But you could be more fancy, and this is what we want to support in OME-NGFF. You could at the same time rotate your sample. You could stretch it. You could do even some warping and so on. Okay, so we want to have very flexible transformations that allow you to render from voxel space into physical space, to enable really all the multimodal data stuff that you could imagine. And so that's the idea. And another concept you need there is the interpolation, because then sometimes, I mean, these physical grid voxels on your screen, they might not be exactly on top of one of the voxels in your data, so but somehow in between, and then you have to also give it some recipe how to interpolate, for example, do some sort of weighted average of all the neighboring voxels or something like that. Okay, so I think these are two concepts you need, and then you can in fact overlay nicely data, for example, of very different resolutions and modalities. And again, we can try this together. So, so for this, we don't have yet, let's say, a very easy Fiji integration. And in general, actually, I think Josh and I think we want to also now apply for a grant, maybe to hire more people that would do that. So I think in terms of integrating all of this in Fiji and all the other viewers, it's still early days. Yeah. So what you see here today is really like the latest thing, but it's not, you already had to install an update side, right? Which is not the situation we want to have. So we want to have all of this really core Fiji, but we are not there yet. We need developers for this and so on. So that's why we have to go now through a bit different route to show you what this multimodal stuff. So, okay, maybe I can yeah, put this in the chat. So you have to now go to open published MOBI project in Fiji. So I will again open P gives you, oh, actually there's a shortcut. You can just do open Platy browser. I realize now. That's one as a even faster way to get there. Okay, take that one. Okay, the search bar, so useful. Okay, click run. And first of all, you see again the same image. And because this was actually the one where we set all of this up. So now what we can do is we can add, oh wait, or maybe that's even, okay, I will not now take any risk. So let's add some fluorescence data on top, okay? And there is this on the left, you have all these drop downs, and there's this Prosper drop down, and I want to add a data set that's called Olig. Okay, so on the left in Prosper, select Olig, and then click View. So now it added this image again, lazy loading it from Object Store to Big Data Viewer. And this is in fact the fluorescence signal of a gene that should be expressed in the eye of this ECS. And now to find the eye here in 3D in this 8 terabyte data set can be a bit annoying. So, but we have here a so-called bookmark, which is called adult eye. So if you click on bookmark, adult eye, and then you say view, it will move the view of the data viewer to this eye. And then you should now see this really high resolution EM, and together the much smaller, lower resolution fluorescence data. Maybe again a little yes or something in this chat, if that's fine. And I have a feeling we're still following. Okay, cool. Yes, Judith is still very enthusiastic. Okay, and the cool thing is now, if you again use your mouse wheel, this is all, I mean, you can move around. Yeah, this is not this is really sort of fully, and I could honestly do this for a long time. I think it's really fascinating, all this morphology here, but not unfortunately not the point. I think this is some photoreceptor stuff. I forgot the name. Okay, so that's the thing, and then I want to show two more, or actually yes, some other things. So I think looking at all that stuff in Big Data Viewer is absolutely awesome, but sometimes you also want to do use just a Fiji plugin, right? And do something, or measure something, or save it as a JPEG or whatever. So I think what we also need for all of this is some way out of this multi-resolution, fancy physical rendering into just some normal voxel space back, okay? And we have here currently two things that I want to show. So if you now right click on this eye, the upper two are interesting. So and let's try together. So this take screenshot is one way how to get back into the more traditional ImageJ world. So if you click take screenshot, and now you can say, what's the resolution that I want for my screenshot, okay? And this is now in the scale that's down here. So this is micrometer. So, and if you change this a little bit in the log window, it will tell you how big the image would be if you were to take this screenshot. And that's good, because if you do something very small there, it might be like a terabyte screenshot and you might wonder what's happening. So it's good to check always that this is not getting sort of out of hands. But so this would be now at a resolution of 100 nanometer. Maybe I'll be a bit ambitious now since this is all going so well. Okay, so I will try 10 nanometer resolution screenshot, and I keep both options active, and I think you should do too, because that's also conceptually interesting. So if we say now, okay, now we have to wait a little bit because it has to now load the data at a higher resolution than it's actually rendering it right now. Okay, so that means the object store is, now I wonder whether I have been sort of too ambitious. But that's just like, that's a good point. Is someone already finished? No. Aha, okay, I'm there. I'm getting there. Okay, so this is the sort of first option, and this is really an RGB image. Okay, so not maybe something you would want to use for image analysis, but the reason we did that is because we wanted to have something that looks exactly like it looks at that moment in the data viewer, okay, with all the color rendering and all of this, okay? So this would be sort of the beautiful version that you can still save now with normal ImageJ as a JPEG and put it in your publication or something. But it also gives you here really the raw data, okay? So, and there you actually see that this is this gene expression image has not a very nice resolution. Yeah, it's essentially, you see really the pixels. Yeah, so I think, but this is then, so these are really the pixel values that are. If you go with your mouse over in Fiji, these are close to the values that you have in your voxel data, but they're still interpolated, okay? Because we are actually still cutting probably our data at some weird angle. So that's sort of in between, yeah? So you get your raw data, but not really the raw data, yeah? That's not on the voxel grid where you saved it or where your microscope has acquired it, but it's some interpolation of the values in the voxel grid, okay? So, so that's just, you know, if you deal with all this multi-resolution stuff, it's just things one has to sort of get used to a little bit. Okay. Did it work also, for example, Christian? Not yet? What, okay, what's your capture size there? Is it even bigger or?
No, I took the same one. And it's still not loading. Maybe I can
maybe
try with the smaller one.
Yeah, I'm not sure how good my multi-threading is, whether you can do 2 screenshots at the same time, but we will find out. If it hangs, then it hangs.
But also just watching it on your computer is impressive enough, so it's fine.
Okay. Anybody else successful with the screenshot? Okay, good. Then at least it's not a bug. Then it might be, I don't know, yeah, interesting. Okay, you can also try. Works, no. Okay, let's try something in parallel. 50-50%. Maybe it just will still come. Okay, let's see. Again, I'm not sure. Let's see, but okay, we can, okay, work well. Okay, so yeah. Maybe then, okay, you can risk to do the, okay, so because then if let's say you really want the raw data, okay, then you can right click and say show raw images. And then it actually really looks into this whole voxel grid resolution pyramid, how the data is stored there. And this would be the 8 terabyte, which you don't want to click, okay? So I will now, for this to be fast, maybe just be like, I don't know. Okay, I think for me it's probably faster here. So I think I will try, or let's try this one. So this is a very relatively low resolution version of this data. Okay. And then it asks me now, because there are 2 images displayed on top of each other and they have both different voxel grid backings, let's say. So I have to make a choice for both. Okay, this is the gene and the other one was the EM. And then it opens them in Fiji. And now actually at the orientation, how the data was really acquired, also really with sort of the raw voxels and nothing going on in terms of, you know, all this oblique interpolation, rendering and stuff and so on. Okay, so this is another way how to get at your raw data. And maybe if we have time later, I think this is also, we had discussions. Be interesting from you to learn what you would need, right? Or we as a community, what sort of, like, let's say we have now data stored in such a way in the cloud, how would you like to actually access it? Right? Is this already covering all the use cases, or, you know, that would be actually for us, I think, interesting to know. Okay. Did that work? Oh, so who managed to get the raw? Yes, yes, yes. Yep, okay. No, okay. Good. I mean, this is also stuff we have to learn now. I think it's really early days with all of that. And then maybe, yeah. Christian, maybe try again with a smaller, maybe thing later or something, would be curious, yeah. If that was, like, I don't know, yeah. Good. So that's basically sort of accessing. Oh, no. There's one more thing. Okay, let's actually, okay, I'll close. Let's maybe restart Fiji. Okay, let's all restart Fiji. And then have one more example of accessing such data. And then we can maybe have a very short break. Okay, I open the Fiji again. Okay, and then go back to my presentation. So I think the idea actually, or one idea, is to have a lot of such data in such formats. For example, at the bioimage archive, and then, but then also you can have, you know, you can just also make your own website, for example, if you are totally into Drosophila or something, right? And then you can put links there of interesting views on Drosophila data sets that might be good for your community, or some COVID related stuff, okay? And how that could look like is shown here. So, okay, wait, Josh, can you put the... So this is where the OME consortium, in fact, put just a collection of links to different data sets. And they are all, you know, stored in this way. And then you can just, you know, send somebody a URL and, for example, tell them, hey, just open this into T, okay, without needing to download anything. And I mean, actually, you can probably use, you can be sort of maybe just whatever you like, okay? But if you want to use the same one that I use, I think I will use this one here, IDR. And then on the very right here, there is a button called copy. So the IDR 0062, and in fact, the upper one, copy. Okay, and then here again, I do OME, open OME var from S3. Run, and then I paste, and I have to remove the other stuff before, yeah, so don't have two links, so it should look something similar to this. So open only var from S3. And I think I don't want to see the chunk loading now. We have seen this. And this takes a bit longer for me now, and maybe that's because I'm a bit further away from the EDI in England than I am from EMBL Heidelberg, obviously. I should have left on the top chunk loading, then I would know. Okay. Okay, and then some point it comes, and as Josh said when we prepared the course, it looked very ugly, and I agree. And the reason it does look ugly is that, in fact, what we don't have yet in OME-ZAR, because we're all working together on the specifications, we don't have yet any specifications for the rendering settings, like which colors should we use and stuff. So here now it opens it in a pretty random way. So for those of you that are interested and want to learn a bit big data viewer, I will just show how to manually make this now a bit nicer. So if you go with your mouse to the very right of the big data viewer window, there comes this little arrow. You can also press P on your keyboard. And then you see that it in fact was loading 5 images. So in big data viewer, each channel is 1 image. That's maybe something to get used to. And the last one is actually something special. I will uncheck it now, and maybe we can talk later about it. Josh shows that in another viewer. And then just click on the first one. This might be a bit fast now. And down here are the min-max that you might know from ImageJ. And I tried before, if you type here around 3000, then you actually start to see something. And then here you can change the color. For example, I could make it blue or something like that. Then I could, for the second image, also I think 3000 as a upper value was good. And I could make it, for example, this color. Okay, and you get the, okay, this is bright now. Okay, so I think you get the idea, right? So you can just, like in ImageJ, configure the channels and the colors. And the other take-home message is the reason that you have to do this now by hand is that you don't have yet the official specification for this new file format, how to actually represent that. That's why one had to do it by hand. So that's still missing. Okay, yeah, so that's sort of the idea, okay? So you can just put these links somewhere, organize them in a way that you like, maybe some project-specific website, and then you can, like, in a nice way, share all of this with your collaborators. Good. Any questions so far? Here, so if you have your Fiji open, you say File, Open Samples, MRI stack. Okay. File, Open Samples, MRI stack. Probably the image I have seen most in my life, because I use it always if I just want to try something. Now, since we have now all this nice scaling transformation, we actually want to put something there that makes sense, because this is in fact an unscaled data set. So I want to go to Image Properties. And I am actually not sure at all, but let's just pretend millimeter. And this is somehow new in Fiji. If you just type millimeter in one of them, it will use it for all. And I tried before, the aspect ratio is such that we put a voxel depth of 7 and leave the others at 1, then it looks sort of not completely wrong, yeah, in terms of that it should be ahead. Okay, so the only things I changed was I put here millimeter and I changed from 1 to 7. Okay, just 2 fields. That this thing actually now has some sort of scaling. And then we want to save it as an OME-ZAR. So I'll again just type OME space and hope for the best. And indeed, the 5th entry here is export current image to OME-ZAR. Okay, export current image to OME-ZAR. You can also find it in plugins, Big Data or OME-ZAR export and so on. I click run. Okay, make sure your voxel size and unit are set properly. Of course, we did that. Image name, whatever. I have MRI here. You can type something else, and then you have to tell it where you want to save it. Maybe some folder on your desktop. So just select something here. I probably would just make a new folder. Downsampling method, that's for more advanced people actually interesting. So if you make this resolution pyramid, you somehow have to get from the higher resolution to the lower ones. That means you have to do some sort of averaging. Yeah, and an average is one option, but for example, if you have more like binary data or label masks or so, you don't want to do this because you don't want to have a half binary pixel, right? It's either 1 or 0. And that's why we added here 2 more options, which I think they both would work. So the one below average just uses the center pixel of the thing, of the block that you want to downsample, and the mode would use the pixel that occurs most often. And they would both work for if you have like label mask images or binary data. So then you should not use average because that would screw up at lower resolutions. So that's important. Actually, I learned that sort of by doing it wrong. Okay, then yes, just defaults, fine. We say okay. And then it says I do it. And now I have this folder on my desktop. And here, as promised, it looks like I had in my presentation. So I'm not sure. Oh, I have to make it bigger. Good. Okay, right. So this is now, okay, and since this is not such a big image, it decided I don't need really a resolution pyramid, so it only saved the highest resolution level. And here it's, again, it's a 3D image. That's why we have here like a 3 deep nesting. And I'm, to be honest, not sure, is this now first set XY or XYZ or whatever, Josh, do you know? Or is it?
ZYX.
Okay, ZYX. So that would be then the, well, I don't know, lower left corner. And actually these files here, really, you can't open them. This is just binary files that they really contain just the voxels, okay, that are present there. So you can't open them like that. In fact, maybe the best would be to just open this file again, for example. Open OME-ZAR, and now we need from file system, okay, because now it's on our computer, so, and not in the cloud. So open OME-ZAR from file system, run, and I can in fact browse there, and for me it was already there. And I think you have to click on that level here. So the thing that actually contains .ome.zar. This is now, let's say, a bit more complicated than with a normal image file because you have all these folders. So you have to practice to click on the correct folder. And here, the one that ends on .ome.zar would be a good one.
And you have a question, Tischer, when you're ready.
Good, yeah.
Does the save to OME-ZAR function work on virtual stacks that don't fit into memory?
Theoretically, yes. Maybe you run into the same problem that we ran into, that it has a memory leak somewhere, but I think in theory it should. So please try it and then get back to us if it doesn't. Okay, and then we have it, we can open it and look at it and so on, okay? But that's, let's say, already boring because we know all of this. Okay, then maybe what I feel, or maybe I can just give a short glimpse and then Josh can take it from there. So because what we then also wanted to do is discuss with you a little bit more about the inner guts of this OME-ZAR, but I think, so on my Mac, in fact, so we have to look at these hidden files. These are sort of more interesting than the binary files. And on the Mac, I found out if you do Command-Shift-Dot, you can see them. And I think on Windows, I hope the Windows users know there's somewhere an option to say show hidden files. And then you can see these files that start with a dot. And I will open one of them with a text editor. And then you can see what's in there. And it's pretty minimal, okay, which is good. So we have specified that we have axes, and 3 of them, a z-axis, a y-axis, and an x-axis. We have also specified that they're of type space, yeah. And I, to be honest, now already getting at the edge of my knowledge, there might be, we have also time, maybe. Do we, Josh? John? I guess we have also time and channel, because this is the, let's say we support spatial dimensions, time and channel. Okay, this is what most viewers do, and they can have a unit. Yeah, millimeter. Then for time it could be seconds, and for channel they have no unit as far as I know. And you cannot imagine all the discussions that we had in the last years to come up with this. But okay, and then there is now this transformation that I was talking about, which is what you would typically know from other file formats as just a metadata called voxel size or pixel size. So we try to be here a bit more general and say this is actually a coordinate transformation from data space to physical space, preparing ourselves for doing more complex things than just a scale. But this would be just a scale, and the scale is here 7 for set and so on, yeah. So it's a bit different philosophy than what you might be used to from most file formats that you looked at maybe so far. Okay. Any questions right now before the break? Vladimir, can I open it back into Fiji like non-BDV? No, so at the moment, the workflow, well, that we support with this Mobi plugin is actually just this loading it in Big Data Viewer. And what I now added is this right-click show raw images. And that actually then gives you the like the normal image, okay, but the thing that we want to work on, I think with you and John Bogovic, right, is basically this other way of maybe directly getting the voxel data and not the physical data. Vladimir, does that answer your question? So what you are asking is exactly what's sort of missing, what we want to do. Or what maybe you even will do. Okay, any other? Yes. No, exactly. That's the point, I think. Yes, cool, thanks. Where did you find the .set attribute file? Yes, it's a hidden file. So it's directly, I mean, the one I looked at, yeah, there are several. Here you can see it. The thing is, you just need to, I think you have Windows, Niels, huh? So you have to somehow say show hidden files. Yeah, cool. Any other question? Is there a way to change the metadata only? The metadata only, or is that something that we want? Josh, yes.
Yeah, so I mean, we've certainly done this. So especially if you've written just a ton of data in this format, you don't want to rewrite all the chunks if you don't need to. So for the IDR, we have gone in but it's all a custom script. So, you write some type of updater that goes in and, fixes whatever the change is. I think we want the libraries to do that as well. You could imagine Fiji, or I don't know if it's specifically Mobi or if it's Fiji in general, someone opens a file and you say, oh, we noticed that your file's a little bit old. Would you like to update to the newest metadata, assuming that you don't have to rewrite the data, right? I think we can automate this. That certainly works at the OME-XML level, so I think it's feasible.